course schedule. There are a total of num courses. Num courses you have to take, labeled from 0 to num courses -1. You are given an array of prerequisites, where prerequisites I is equal to AI BI indicates that you must take course. I haven't done this one. Yeah, I haven't done this one. Indicates that you must take course BI first if you want to take course AI. Okay, for example, the pair 0, 1 indicates that to take course 0, you have to take course 1 first. Cool. Return true if you can finish all courses, otherwise return false. We have 2 examples here. Num courses 2, prerequisites 1, 0. True, there are a total of 2 courses to take. To take course 1, you should have finished course 0, so it is possible. Okay. And then num courses 2, prerequisites this. False, there are a total of 2 courses to take. To take course 1, you should have finished course 0, and to take course 0, you should have finished course 1, so it is impossible. Alright, so first thing first, I'm just going to set up the function signature. I deleted it on purpose so I can just practice writing this out. Usually you don't get this in an interview, so you have to write this out by hand. We have num courses, and we have prerequisites, and then the return type would be a boolean, like that. And then just to make sure I got this correct, oh, list of list. Oh, my bad. Oh yeah, you're right. Yeah, my bad. Oh, list of list. Okay. Can finish. Self num courses. Prerequisites list. So if I do can finish, it looks like it matches. Yeah. I'm curious to see. I want to try using the one I defined to see if it breaks when I try writing the code later. Now, just some starting off questions. Num courses, what's its range? Can it be 0? I'm assuming not because you have num courses -1, so I'm assuming there's at least 1. What's the highest it can be? Can prerequisites be empty? How many elements, like what's the maximum range? I'm assuming the sublist always contains 2. Yeah, like a pair like AI BI. There's probably a relationship between num courses and prerequisites. Or maybe not, I don't know. Yeah, just some questions there. I guess the numbers itself, I did ask about that too. Let's see. So, okay, num courses is 1. So there is at least 1 course, and that's going to be 0 if it's 1. It'll be up to 2,000. The length of prerequisites can be from 0 to 5,000, so it can be empty. And it can be as high as 5,000, good to know. It's good to ask about the upper range because then it gives you an idea of whether or not you have to go for an optimal solution or whether you need to go for more of a brute force solution. Because if it's a higher number, usually that means there's more of an optimal solution to solve it. But if it's just like 8, for example, then brute force can perhaps be suffice. Length is 2, yep. And then the actual course itself can be from 0 to num courses. Should it be num courses -1? All the pairs are unique. Ah, I didn't consider that. That was a good one. I probably shouldn't have looked at that, but I did. Good question. All right, so kind of as a starting point, solving this as a human, I see there's 2 num courses. Wait, so if there's like 5 and then there's, or if there's 2 and then they introduce like 2 in this prerequisites array from nowhere. Oh, it's less than. Not less than or equal to. Okay, makes sense. Okay, cool. So that won't be a possibility. But then in this scenario, to take course 1, we need to take course 0 first. Done. That's all. So there are total num courses you have to take. Okay, so this is the number of courses. These are the courses we have to take, 1 and 0. So just to create like we have 1 and its prereq is 0. We have 0, or maybe I can just start off with 0. 0, prereq, none. So we can take course 0, right? And we're good. And then for course 1, we just have the prerequisite 0, which we've already taken. So this to me looks like some kind of an adjacency list, right? Where 0 is empty because there's no prerequisites, and then 1 has 0 because that's the one prerequisite that we need. And then on each element, we kind of run like a graph algorithm or something, right? We check 0 and then check all the elements in that and kind of go forward. Whereas here, so for example, if we start at 1, for example, we see that there's a 0. Okay, then we go into 0, right? And then check 0's prerequisites, there's none, so 0 has been successfully taken. 0 here has been run, and now 1 can be taken. Okay, like the course can be completed now, and so now 1 is complete. Now when you have this kind of scenario, if you take 1 first, then you see you have to take 0 first. Like that's 0 is a prerequisite, you take 0, and then you see a prerequisite is 1, then come back to 1, prerequisite 0. So it's a cycle is going on. To stop it, you need like some kind of a visited set, maybe. But this seems a lot like a depth first search approach because of the recursion that we're doing here. Is there something else to this problem that I need to consider? I don't know. So we create the adjacency list. And after we create the adjacency list, we go into any of these elements, and then we have to run depth first search on the prerequisites. If it's empty, then we can return true. And if it's non-empty, we have to run DFS on it. We need some kind of a visited set to keep track of which ones we've already visited. I'm blanking out on how a depth first search works, but I think that the visited kind of idea makes sense. We don't need a queue, right? Do we? I don't know. I don't think so. Maybe. Let's stick with the visited set for now and see how that goes. All right, we're at 10 minutes. Am I in a good place to go this? I guess I should talk about the time complexity and space complexity of this approach. though I feel like I haven't really thought this through properly. I mean, this was kind of how I did it as a human. Just kind of made a list and then kind of translated that to code. In terms of an algorithm on how I'm going to write that DFS, maybe I should think that through more before writing it, but I think I'm just going to dive in because that's, like, I started visualizing and understanding things a lot better. Pseudocode, I don't know. I don't think I can properly brainstorm DFS in the comments here. Time complexity, let's see. And then space complexity, we have the adjacency list, right? And that's O num courses. Well, let's say let's define let n equal to num courses, right? So O of n, and then I guess we have the prerequisites as well. Does that count as space complexity? Do we need to consider this? I don't know, but I'm just gonna stick with this. But I don't know. I'm having my doubts. Maybe I should do something like this, where let p be equal to the length, or be the length of prerequisites. I can't spell prerequisites. There we go. You know what I mean? I don't know. I'll stick with n for now, and then maybe I'll think that through properly. For this, yeah, n times p. The reason why is because for depth first search, the time complexity is first vertices times edge, and n is basically the vertices, right? These are the vertices, and the edges are p. Yeah. And then I guess following that logic, space complexity should be O of v, the vertices, and we've done that right there. All right, let's try this. First I need an adjacency list. I guess I'll do a default dictionary, set it to a list, and then for prereq and prerequisite, we want wait, am I doing this wrong? Or am I doing this right? No, I'm following this one. Yeah, to take course 0, you need to take course... to take course 1, you need to take course 0 first. Yeah. Okay. Prereq is equal to maybe dot append. Prereq 1 for that. I think that should be good. And then how do we do this depth first search? We want to start off with 0. And then just return, because that's going to be a boolean. I don't know. Course. If length of adjacency list course is equal to 0, return true. Otherwise, for prereq in adjacency course, we want to do depth first search prereq. And we need a visited. So like this, maybe visited dot add course. If do we need to be popping it out, by the way? Or am I... what I mean is, like, once we come here, deal with the 0, like, pop it out like that. Maybe. If prereq in visited return false. I don't know. Maybe I'll do something like not invisited. Like that. Or am I... Does that make sense? That doesn't make much sense. Okay, hold on. Let's run through the simple example here. The 0. We do 0. We add it to the visited. If length of 0 okay. So we actually need to do something like for course and adjacency list if DFS course equal to false, then we gotta return false. Otherwise, we return true. Okay, so at this point it's 0, so we return true. Alright. I guess we can do like not, maybe. Where'd it go? And then for 1, again, we add it to the visited. If the length is equal to 0, it's not. For prerequisites and adjacency lists, if prereq not invisited, that. But it is visited. So we did that and it's gonna return false. That's not right. Um. Hmm. Hmm. Uh, uh, um, 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 um. I feel like I need to set up the visited in here. Doesn't make sense to set it. No. Maybe like this, and then just pass in. I'll just pass in the visited. Why not? All right. Oh shoot. Okay. Alrighty. So if prereq not invisited, and it won't be anymore because we have a new set. I guess we still need that visited.add course though. Alrighty, and then it won't be. We do DFS on that. 0, it'll return true. And then we're done. And once we're done, if not DFS, return false. And if it is, then return true at the end. I don't know if that's gonna work. Okay, so for the second example, again, these examples are so simple though. I should be probably working with harder examples. So second example, we have all this. Yeah, 1, 0, we're gonna set it up. 1, 0 like that, and 0, 1 like that. Coolio. Visited set. I don't need to do this anymore. We have this for course and adjacency lists. We have a new visited set, and then we call DFS on visited course, and it's gonna fill right here. So we have 0. So this is gonna not pass. 0. Do I need to return false again here? This feels super weird, the way I'm doing the false and truths. Okay, if prereq not visited, if it is, then you reach a cycle. So for this one, you have 1. 1 is not invisited. Yes, you're correct. And I need to pass in visited at that stage. If not DFS, so again, DFS again. DFS has 1. No, DFS carries 0. Now it carries 1 as well. This isn't true. For that, we have 0. If Prerequisite not invisited. It is though, so we return false. Hold on. Did that? And then if this... Okay, so return false. And then at this stage, we went in, we returned false. If not DFS. Yeah. And then at this stage, we return false. This shouldn't work. Let's see. HCLS. Okay. Syntax errors anymore? Okay. I thought I got that though. Why did it not work? Okay. I messed something up. Because I didn't write it else. Change size during iteration? What in the world? How do you change size during iteration? How do you do that? Bro. What? What? Dictionary change size and iteration. Line 34, line 71. That doesn't make sense. I also need to be doing some kind of like popping or something, right? The way I'm doing it right now is, yeah, because if there's like, maybe to take 1 I need to take 0, to take 0 I need to take 2, and then to take 2, or maybe I am right, I don't know. What am I doing? Is it because it's visited that I'm changing this? Dictionary change size during iteration. How? I did that over here. I don't even touch it later. Do I? Just... yeah. Oh wait, this feels wrong. I don't want to, like, this is the way you do it in with dictionaries. Hold on, let's see. Unhashable type list. Prereq. Oh, okay. I think I want to be doing this prereq and adjacency course. So what I was thinking before. Okay. Chat, help me. Please. my silly brain doesn't comprehend. For course and adjacency list. How do you do? How do you do? I don't get it. Dictionary changed size during iteration. Okay. I'm gonna search up this error. Well, it's being iterated over. But my friend, oh whoops, my friend. Where are you? There you go. I don't change you. The adjacency list stays the same. Do I do anything to change you? I don't think so. Yeah, I don't think so, man. Prerequisites, prereq. Yeah, I have no idea. Maybe it's time to ChatGPT this. Are we? Hold on. Ah. Why am I getting this error? Okay, the user. Oh my god, what is this paragraph? Here, just take the full thing, bro. Oh shoot. My bad. My bro. There we go. Wait, no, in the code provided. Wait, the adjacency list is built as. Why is this so long? Oh my god. What is this? Bro, stop, just stop. Oh my god, bro. Wait. I'm confused. Oh. Wait, do I have? Am I accessing a course that's not already? Maybe that's what's going on. Yeah, pre-initialize all courses. But still, that shouldn't cause me a problem. Because when I access it, it should just create an empty list. That shouldn't even be a problem. That's the whole reason why the default dict is so nice. Huh. Okay, well, I guess I'll just do this. So for course and range num courses, adjacency list. Yeah, that's good. For course is equal to this. Okay. And then for prerequisites and prerequisites, just gotta do that. Okay. So now let's get rid of that huge thing. Oh. Okay. I got my hopes up pretty high. I was like, whoa, that worked. Still pretty nice. But I'm gonna stop here because it's been 35 minutes. And go over to NeetCode to watch the solution. Or maybe I'll try solving this, I don't know. Let's take a look at the very least. It should be, I gave false, it should be true, probably something I messed up here. I don't like the way I returned false and true, like it's really messy. I don't like it. Alright, I'm gonna watch the NeetCode solution and see what clean code they're gonna introduce this time.